So in this example, I'm going to talk about text files and Excel spreadsheets. So text files is the most easiest or simplest way to import data. And first of all, I'm just going to create a notepad, a text file, with some example data, and I'll save it. Now I'm going to use the data path component, the file path component. And this essentially is a collection of file paths, and you can right-click, click on Set One File Path. This is convenient because it'll open a dialog for us, and then I can navigate to the location of the text file. You'll see that it stores the string or the text of the location of the text file. Now, in conjunction with that, I'm going to use the read file component that's built into Grasshopper. And then if I plug the path into it, then Grasshopper will read the file, and you can see that I get the entire file directly read into Grasshopper. Now the fun fact about this component is that it's actually very fast to update. So if I add some more data and I save it, it changes nearly instantaneously, which is sometimes very helpful. And this is reading the raw text directly. So text files or CSV files actually are a great way to be read with the path component. For example, if we have an Excel spreadsheet and I make a CSV file really quickly, so I've just made a really quick file, and I'm going to save it as a CSV file in Excel, which is a very quick way to export simple spreadsheets. I'm going to save it as a comma delimited CSV file. And this is especially helpful with the read file component because the CSV file, if we open it in a notepad, just essentially looks like a list of the items separated by the values separated by commas. So I'm going to go back into Grasshopper, and I will actually load the CSV file instead of that text file. And looks like it may not, it looks like Grasshopper may not like it because it's already being used by another process. That's because I already have it open. So I'm going to close that. I will also close this Excel file. And I will middle click and click on play. And so you can see that we've brought in the CSV file. And I'm just going to skip ahead to processing the data a little bit. Once you have a file like this, you can divide it into chunks, and I think there are some Grasshopper components that can take CSV files and parse them for you, but it's also helpful to start understanding how to deal or manipulate string or text data. And so if you go into sets and text, you have all these different text functions, and in this case we want to split our text into different chunks based on the separator, and because the CSV file is comma separated, we want to use a comma to do so. So when I split my data, you can see that I've split it into these branches. So we have each branch has a name, an author, and a frequency. Then I can use this data and express the data correspondingly. And we can go on about that in future videos. As for an Excel file, so there may be an instance in which we want something more complicated than a CSV file, or maybe we want to stay in Excel because there's a lot of functions that we're using, a lot of kind of complicated macros or cell kind of calculations that we're using, which is oftentimes very helpful. So what I'm going to do is I'm going to open up an existing Excel file. So I've done a little bit more calculation, something very simple. So I'm going to go into Grasshopper and try to read this Excel file. So I'm going to take another path, and instead I'm going to point to the Excel file. And there are many different components I can use. You can use GHOW has a spreadsheet reader, but you actually have to install a Windows component to do that. And since many of you may be working on Avery computers, I'm going to use the Excel static read or Excel dynamic read plugin. And so for this, if you connect it into the path and set this to true and give it a blank range, which I'm assuming reads all the sheets, then you can see that we have received the input from the our spreadsheet correspondingly. And so if we change any of this information, I'll do that and I'll save. And I'll have to middle click and play it again, or recompute the answer. That's what the play button means. Then you'll see that the frequency has changed to 3. Now you can use the Excel dynamic range to do that, and it'll update dynamically. Do the same thing. And so now you can see that what we get is now very similar to what we have over here. The difference being that in this example, each column is itself a different branch, and in this example, each row is on its own branch. And if you wanted to convert from this to this other one, what you can use the function or the component called flip matrix. And what this does is, if you can imagine this as being grouped by branches and having these two sub-branches within them, flip matrix will kind of flip that orientation or flip that order so that the sub-branches are actually the grouping method, and the larger branches, they're all grouped under the large branch. It's a little harder to understand and better explained as a matrix, because really what it is if you can conceptualize, and I'm going to simplify this, if you can conceptualize this being the author component being in row 0, column 0, and frequency being row 0, column 1, and these to be columns of a matrix, these to be rows of a matrix, then by flipping it, or getting the inverse in matrix operations, then this will be the row, so this 0 number will be the row, and 1 will be the column. That may be a little obtuse, but it's oftentimes, as is the logic with Grasshopper, it's much easier to do it to understand what's going on. So if you do that, you can see that now it's grouped everything by the first sub-branch, and then grouped everything by the second sub-branch. And so this is very similar to what we get over here. Vice versa, we can also take this information and put it in a flip matrix function, and we get something similar where you have, author frequency deviation. So we have these kind of categories, and then the data distributed here. So flip matrix is very helpful when you're trying to do that operation. So that's how we read in Excel spreadsheets and text files on your computer. And kind of with this format, you can pretty much tackle most basic text formats and most kind of data that you want to bring in. If you have anything in Google Docs, you can export it to Excel. So that's how you can deal with large data sets. And so for a really quick example of how one could possibly use this, I'm going to make a very, very quick visualization, which takes this data and just organizes this as a bar chart in Grasshopper. And it's simple enough, but I'm just going to do that so we can see what the process would be. So first of all, I'm going to get the length of the items, and in fact what I want to do is I want to get the number of branches. So I'm going to use tree statistics, and doing that I'll get the number of branches, or I'll get the number of paths and branches in the tree, which are 9. So what I want to do is, when we want to iterate 9 times. So this creates a number between numbers between 0 and 8. And I want to have a series of points, let's say. In fact, let's say I want to have a series of boxes or spheres. That may be more helpful. And I want to move the spheres then in the x direction like so, 9 times correspondingly. But I also want them to be more of a space between them, so I'm going to increase the spacing between the series. So this is great so far. And let's say I also want to increase the size of the spheres based on the frequency of the author. Now one way I can do this is I want to get all the second items in the list, and because I've already the flip matrix is in the right way, what I can do is I can get the list item. I can say, well, give me the second item, which is on index 1, just because you notice that's how Grasshopper works. Like most programming languages, it starts at index 0, goes to index 1, so the second item is of index 1. So I see what I'm getting, so you can see that getting the first index 1, or the second item, gives me all the frequencies. Getting the 0th index gives me all the authors. The problem here is I have this frequency in here and I want to take that out. And in fact, a faster way may actually be to take the first entire branch out. So what I'm going to do is I'm going to go to the tree split component, and here, or it's split tree actually. And what this does is that using a mask or kind of a query to flip it against, or a mask to split it against, it will split the tree. So, for example, this is my given tree, and I want to split it based on path 0. So I'm going to type in 0, and that's actually a path. So I can say, use that as my mask, and split my tree. So if you see what we get, this is what was matched, and this is everything else, which is perfect. So then I can plug this into here, and so you'll see this. Now I only get the data, and I only get the authors without the initial heading of author and frequency. So now that I have these 9 values, I could plug them into the spheres and the radius. Now I'm going to do this, and this is not going to work because this is grafted. The list itself is grafted into a tree, while the series values are not. So I can do either one of two things. I can flatten this, and now you can see that the sizes of the spheres match up pretty well. Or I can undo that, and I can graft this one instead, and we get a similar phenomenon. Now you might also wonder why that one is there, and that's because we're seeing the initial sphere. So if we hide the sphere, then we can see this distribution of different spheres that are in line with this list of numbers. And now let's say we also want the names of the authors somehow displayed next to the spheres. I'm going to use the text component, the text 3D component, 3D text tag. And I'm going to have this be the text, and I need the locations. So what I'm also going to do is I'm also going to I could do a few things. I could get the sphere, and I could use the volume of the sphere to get the center of the sphere. This isn't the smartest because we've created the geometry and then we're getting the center. What I could also do is I could use the center point of the spheres, which was 0, 0, 0, and I can also move that in a similar way. So I've got the center point of the initial sphere, and I'm moving it the same way that the initial sphere is moving. So now I have these points that I can plug into my locations, and you can see that I can see the text being printed out. I can modify the scale of the text, and then finally I can color everything and make everything a little bit neater, as I've been emphasizing is a very helpful thing to do within the scope of your tool. And now go and hide everything that is not important to us. So then you have this kind of very quick and dirty visualization representation of this Excel spreadsheet. And since again this is working off of an Excel spreadsheet, or in this case it's working off of a text file that's reading a CSV, we can go in and edit that CSV. Whoops. So I'm getting a memory error. Okay, great. I'm going to edit that CSV. You save it as a CSV file. I'm going to close that out. Yes, I do want to save. And then I'm going to use the play button to recompute. And you can see that the distribution has changed accordingly. So that's the most direct way in which you can receive input from Excel files or text files.